Okay, welcome to this online interaction session for this course, Microwave Engineering. So this is a rerun course and being rerun for the third time. So we have uh, actually about 1100 plus registered candidates, and we are in the 7th week of the course. We have already covered the basics of transmission lines, rectangular and circular waveguides, microwave networks, microwave resonators, and power divider and filters. And this week, I think we are going through the microwave semiconductor devices. So quite a good amount of topics have already been covered. We are uploading the assignments every week, and our TAs, they are taking care of the assignment. Moreover, we have one PMRF candidate from IIT Madras who is also interacting with the interested learners. So with this background, I ask welcome the learners who have joined, and if they have any queries regarding any of the topics that we have covered so far, you may please raise your queries, interact, and get your doubts clarified. So Elin, any learner who is, yeah, please go ahead. Please turn your camera on and you can ask your queries. Mr. Sudeep Chakraborty, please.
Yes, sir. I have a doubt. This doubt is actually in my mind for a long time. Actually, when we
Yeah.
study a two-way transmission line like objects, actually we come across this concept that there is a reflection going on. There is a reflection which occurred in this when we send signal in a two-way transmission line.
Mm-hmm.
I I studied and analyzed that subject and discovered that since at the load end, if the line is terminated, if the since if the line is terminated, and where I analyzed that since there is a mismatch in the differential equations, that's why there can be one reason that reflection occurs. But why reflection actually occurs, that is my actually question.
Yeah. So suppose you take a transmission line. Huh? If you solve the general equation for the transmission line, you will have two waves. One is going towards, say, if z is the direction of propagation, so one is going towards plus z, another is towards minus z. Now the question is when both these will be there, or whether it will be there always. You have rightly said when there is a reflection comes when there is a mismatch of load. So a transmission line has a characteristic impedance. Ideal cases, we talk about the lossless line. Practically also, the lines are designed to have very low losses, and characteristic impedance will be, say, 50 ohm line, 75 ohm line. So it will be real. And therefore, when you have a load connected and it is not same as the characteristic impedance of the line, then the load will not be able to absorb all the incident power, and some power will get reflected. And this is how you get a reflected wave. And in fact, there may be multiple reflections also, because if your source is not matched properly to the line, we'll study that multiple reflection. Uh, then you will find that the wave will come get reflected again from the source, but it will travel to the load again get reflected. So there are multiple reflections also possible. It depends upon the degree
Yes,
of
yes.
if your line is matched. For example, if your line has a characteristic impedance of 50 ohm and your load is also 50 ohm, you won't get any reflection. If your source has a impedance of 50 ohm, you will not get a reflection. But if there is a mismatch of impedance, then you will get reflection. And you know that reflection coefficient, if you remember, we derived that it is ZL minus Z0 divided by ZL plus Z0. So if ZL is
Plus
Z,
Z0.
Z0 is the characteristic impedance. So, and ZL is the load impedance. So if ZL equal to Z0, reflection coefficient is 0 and you won't get any reflected wave. Then what will happen? All the uh, signal energy that is incident on the load will be absorbed by the load. But if you do not have this characteristic impedance same as the load impedance, then there will be reflection. And this is what we cover also in the topic of impedance matching.
Yes, yes.
So we use section of transmission line or L element or C element, and then we try to match the load to the line impedance so that reflection is minimized.
Yes, sir. Yes, sir. That is the concept. And I also analyzed that when we study that matching of load for a DC case, like any lumped circuit model, when
Hmm.
we analyze this concept, there is also told that maximum power will be transferred in a network load if and only if the load impedance equals to the input impedance of the network.
Hmm. Hmm.
It is also told there. And I am
And
I have
so
analyzed the same words here also, but here the concept comes a little bit different actually.
definitely it is at higher frequencies and you are considering the waves, voltage waves and current waves. Ultimately, it is the mismatch. If there is any mismatch, there will be reflection. When it is matched, there won't be any reflection. And matching here, we mean that reflection coefficient is 0 when ZL is equal to Z0. If you have studied the equations properly. So this is now, it also depends upon the loss. If the line is slightly lossy, even if there are multiple reflection, the wave will attenuate as the signal propagates, and after multiple reflection, those reflected signal will be very, very weak. So this is how things are modeled.
Yes.
So you are studying BTech,
No, actually, sir, I have just passed BTech this year.
huh? Oh, you have already completed.
Yes.
So preparing for some competitive exam.
No, I am waiting for MTech in my nearest university, Jadavpur.
Okay, okay, okay. Good luck. So any other question? We move to the other learners present in this interaction. Supriyo Lohar. Supriyo Lohar, do you have any question?
No, sir.
Okay. Then Lakshmi Kanta.
No, sir.
So in general, how you are finding this course? Are you going through all the lectures and trying all the assignments?
Yes, sir.
The course is very good. It explains about the concepts and also gives extra materials that are taught in the lessons. Many a times, many words we forget, and these notes provide us with very much facilities about our forgotten words by failure.
So actually, the course material has been prepared so that it gives a full-fledged undergraduate coverage for various institutes, and also if you prepare those material carefully, you will do well in examinations like GATE and all. And the assignment problems are chosen accordingly so that it gives you insight into the theory, how to apply those theory, what you learned in the course. So if anybody has any other question or any other comments,
Could you tell us, sir, which book to refer? Because I'm still struggling with the assignment.
see this, there are two very standard books which have been followed in this course. One is Microwave Engineering by D.M. Pozar, and another is Foundation for Microwave Engineering by Ari Collin. And when it comes to the tubes and other active devices, uh, we have also followed the book by Liao. So these are very, very standard book and followed in most of the universities. So Pozar's book will cover most of the content that is there in this course, except for the tubes, and Foundation for Microwave Engineering by Ari Kalin also will be a good text.
Thank you, sir.
Yes, sir. I have another doubt in the text that in the term microwave, it tells us that the waves that have a wavelength of the order of micrometers. But in the text we find that the wavelengths range from say 1 meter to 1 centimeter. In text we find that, but the
Yeah,
name
yes,
says.
yes. Microwave does not really mean that it is wavelength is micrometer. Uh, at that time, actually, I told in the very first lecture itself, this terminology was used because at that time, generate the sources that used to generate the waves, they used to generate very long wavelengths. So compared to those, the wavelengths in centimeter itself was very small, and I've given the reference where the term microwave was first used. So don't take it literally that microwave means it is micrometer wavelength.
I have not taken it literally, but the name actually suggests like that.
Yeah,
Actually,
but
that's my
microwave usually from meter to centimeter, this range is covered by microwave. And you can see that millimeter wave has a shorter wavelength.
yes.
But
That also creates me doubt.
so these terminologies become actually accepted or established with time. But we should remember that microwave frequency range, millimeter wave frequency range. So from 1 to 30 gigahertz, you will roughly 1 gigahertz you will be, or if you take say 300 megahertz to 30 gigahertz, this range you will have wavelength of the order of meters to centimeters. And then when you go to millimeter wave, 30 gigahertz and above, so there is the wavelength is still smaller, but we call them millimeter wave, whereas the larger wavelength we call microwave.
Microwave.
Yes. So that is because of the naming that has been done at that time. Otherwise, you remember the frequency range.
Yes. Antennas. Communications.
Sir, can I have sir solved assignments? Some of the assignments, some of the questions I could not solve, sir. Can I?
Yes, yes. The solution of the assignments will be loaded. I can verify with. Yeah. So solution for this will be uploaded.
Sir.
Yeah, you will get the solution.
Yes, sir.
So if you do not have any more questions, so should we wind up this session here, or there are some other queries from your end?
No queries from my side, sir. Thank you.
So it seems there are no more queries from the participants. So our CET may take a call now whether to continue with the session or.
Yes, sir. You can wait for 10 minutes.
Okay. 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 If new participants join. Okay.
Yes, sir.
Okay.
Sir, we are actually studying microwave subject and we are also seeing actually we are using today's smartphones and we are lost in the illusion that the smartphone is giving us all this data. But practically, when we think deeply, their question comes that how can communication be possible because in earlier days the communication was connected using wires with computers, but now how is this connection possible? There comes the solution that we use microwaves that that do our serve our communication purpose of data exchange. But now the question is, there are various words told that since we are in the age of these microwaves, our bodies are now getting affected due to all the presence of these waves. And if the frequency of the waves increases, the human life will start deteriorating day by day. Sir, is this concept right? Actually, if we further increase the frequency more and more.
Yeah, this is the biological effect and environmental effect of microwaves. This has been studied, and there are groups uh, which recommend the safe level. As you have rightly said, for communication purposes, in the beginning we used to use wires. Now we are using more and more wireless. We are moving towards higher frequencies, and there are, see, microwaves is a non-ionizing radiation. Radiations may be ionizing as well as non-ionizing radiation. So non-ionizing radiations are used for communication purposes, but when the frequency is very high or the power is very high, it may affect. And there are international bodies, they provide safety limits below which this can be used for communication purposes, and there are periodic checks also done by the agencies. So this is altogether a different thing. Uh, and you can read more
Actually,
about. Hmm. So
actually,
human,
this thing. Sir,
when you
sir,
when you buy a mobile phone, you please check the value of SAR, specific absorption rate. So that actually gives you, and there are maximum SAR, those limits are there. So you can check whether your phone is below the recommended standard. Similarly, there are agencies who routinely carry out this type of signal strength measurements and check that whether we are within the safe limit. I cannot go into the very details of this because uh, this requires actual data and all.
actually, I asked this question because after talking on my smartphone, after some time, I feel that I am feeling exhausted, like that is happening. That didn't happen when I used to talk using my earlier days telephone. There was no problem, which used twisted pair cable while
Yes,
communication.
actually, uh, there are recommendation is also there how long you should speak. So if you follow those recommendations, you will be safe. Uh, Generally, it is advised that I think around 5 to 6 minutes is continuously what you should speak. Time to time, you need to change your phones, and lot of simulation studies takes place because how it is going to affect the human bodies. Now we have simulators where these phantoms are there and the phone is placed, and to what extent the signal level is penetrating in our body, all these things is done. But if you keep talking 1 hour, and definitely it is your mobile phone has a transmitter as well as a receiver. So when you are holding your transmitter near your body, and if you do it for a prolonged period, you do not follow the recommended limits, then there may be problems.
Exactly, and nowadays, without using smartphones, studying is also not possible nowadays.
Yeah, but usage, there are limits. Those things you should be aware of. That is a altogether different topic. I am not going into these details of this. But yes, there are bodies, international bodies, who provides a recommendation for safe use of frequencies so that people are not affected. But again, if you do excess, use excess power, use phone for excess period of time, chances that harm will be there.
Actually, sir, the name which is on my DP, that is not my name. Actually, my name is actually Shomitra. That is not my
Okay.
name.
But you are showing as Supriya Chakraborty, I think. And Sudeep
Sudip.
Chakraborty.
That is actually because it's my dad's name.
Okay. Okay. Do you have any other query related to the topics which we have covered in the course? Because this program, we are participating because if you have any queries related to a topic which you have already completed. So Susan Thomas has also joined. And can you turn your camera on, please? Yeah. So we had actually few learners and they had some queries. So I tried to answer. And the thank you for helping this course and regularly interacting with the participants of this course and clearing their doubts. So do you have anything to tell about your interaction so far with the participants? Any specific?
Hello, sir. Good
Yeah.
afternoon.
Good
Yeah.
afternoon.
So happy to have this to join this live meeting. So interactions on a weekly basis are going good. So there are few regular attendees who join every week, and they are I guess they are following up with the course better. Yeah. Uh, yeah, but interaction, the number of attendees are little reducing on a weekly basis, as you said before. Yeah.
Yeah, so initially many people are interested, but
Yeah. Yeah.
gradually this I have observed.
Yes.
And
Yes.
the same thing you will see when it comes to taking the examination.
Yes. Yes.
So any other learner, do you have any question or queries? Otherwise, I think our CET people can decide whether to continue because no new learner is joining. Whoever joined, one I think has left and other people have already asked.
Sir, yeah, in the lecture session, you have mentioned about the dielectric waveguide. You have mentioned that waveguides generally are hollow metallic tubes of either rectangular or circular in shape. But you have also mentioned about dielectric waveguides do exist. actually in a dielectric waveguide, I think that there will be more losses compared to normal hollow waveguides. So why these dielectric waveguides are actually used?
Why there should be more losses? How
Losses in the
how loss occurs?
loss occurs because in the dielectric there will be some leakage currents like the changing
So
magnetic field will induce
there may be, if the dielectric has, it's not a perfect dielectric, there will be loss if it is has a resistive component also. Other than this, when conducting the wave, as you have rightly said, the field will remain confined within dielectric, and some part of the field also will come to the media surrounding the dielectric. And in fact, optical fiber is an
yes.
example actually where you do not have any metallic structure. It is made of dielectric, a core and a cladding, and when proper conditions can made, wave can be confined within this. Uh, at lower frequencies like microwave frequencies also dielectrics are used, and depending upon the dielectric constant, uh, it can actually confine the wave within itself. But mostly commonly used waveguides are metallic waveguides or coaxial lines.
Yes, waveguide. These are used. I have also another doubt that in studying your transmission lines, we have actually considered the steady state conditions on a transmission line.
Mm.
What will be there in the steady state? But I have a question regarding what will happen in the transient state when the transmission line is just connected to the source, and what will happen at the time of rising of voltage at the load, meaning rising of energy. That is, I have a question. How will that rise?
Yeah, so transmission line normally we study under sinusoidal excitation. So our source is a sine wave, and that's why sine or cosine. So that's why we called it is time harmonic, and it has a frequency omega. You can use transmission line also for sending pulses. Now, depending upon the characteristics, the pulses will propagate, they may spread, uh, and the rising transient analysis, when there is a rising edge, those things will, and when there is a falling edge, so those things you can perform. You know the equivalent circuit of the transmission line.
Yes.
Yeah, but what we have studied is the behavior of the transmission line under sinusoidal. When I say sinusoidal, I mean both sine and cos excitation, and that's why we call it time harmonic. And if you have noticed, we have used phasors. So actually, the voltage or current will be a function of both distance and time.
Yes,
and
yes.
and to get that equation from the phasor, you will have to multiply by e to the power j omega t, take the real part of this, then you will get the equation of the propagating waves. And this is under steady condition.
Yes. So for analyzing the transient state, where I have to consider the circuit model, then I will understand what actually happens in transient conditions. Like when I just connected the source of power, what will happen?
Yeah. So that part we really did not consider in that way. We have considered sinusoidally steady state. So I could see no new learners are joining. Sweetie, what should we do?
Sir, you can stop the session, sir. If no students is there, so
Yeah.
you can stop, sir.
So thanks everyone for joining and raising those questions. And I also thank Susan Thomas to take out time and join this session. And I hope that you have very good interactions with the learner in the next few sessions. And if you have any particular queries asked by the students which you feel should be referred to me, please don't hesitate. Please send it to me. And there are, I will ask our TAs to upload the solutions of the assignments which have already been there, because there are some requests and there is a provision of doing that we will take care. Okay then.
Thank you, sir.
Thank you. Bye.